Okay, so chord being our first one. Draw another chord. Another chord. Example 3. And I'll try and go from like easy, medium to hard. How's that sound? So again, chord. We are not finding the angle. Before we had a little 1 here in the corner, and we found the angle by his arc, his vertical partner's arc. We added them and divide by 2. So now we're finding segment lengths. And so this formula of the parts times each other will help us. So in the first one, I have an X and a 3, and a 6 and a 4. Can't be any easier. So you pick one chord. It doesn't matter which chord it is. I'm just going to pick this chord, and I take its parts and I multiply them together. I think the hardest part about this one is sometimes in the worksheets and the textbooks and like the pre-made quizzes, the 6 might be floating out in space, and so sometimes I don't know which part the 6 belongs to. So if you ever have a question, just yell. And then set that equal to those 2 times each other. So 4 times 6 is 24 equals 3x, and we simply divide, and x is equal to 8. Can't be easier. Do you agree on that one? Okay, let's get a little bit harder. This one, we've got a 2 and an x plus 1, and we've got a 4 and a 3. So parts of one chord, it does not matter. So I'm going to take the 4 times the 3 for this chord. Now I'm going to do the 2 parts for this chord, so I'm going to take 2. But promise me, anytime you have a binomial or bigger, I want you to put it in parentheses. Because if you don't, then sometimes you'll lose that distributive property. So part times part equals part times part. So 12 equals, and the distributive property would be 2x plus 2. Subtract the 2 and get 10 equals 2x, and divide, and I get 5. Okay, how's that one? Okay, a little bit harder. On this part, the 2 parts are x plus 2, x plus 1, x plus 4, and x. So we got x plus 4, x plus 2, and x. We got a lot, all good parts coming up there. Someone set it up for me. And I don't care which chord you start with.
You do x parentheses x plus 4.
Excellent.
Equals. Would you put?
Yep.
Just put 1 in parentheses.
No, I do it. Yeah, do both.
Okay, x plus 2 and then x plus 1.
Excellent. So promise me and make a little note on the side there that if it's a binomial or bigger, put the parentheses around it, because then it'll help you make sure you're doing the right thing. Because on the left-hand side, it's the distributive property. So I would get x squared plus 4x. On the right-hand side, what is it? Yeah, what process is that weird one? FOIL. Yeah, so write FOIL above it. X squared plus, excellent, plus 2. Now I made this one nice because what happens with the 2x squareds when they're on opposite sides of the equal sign? Yeah, I made it nice on purpose. So the 4x would come down, the equal would come down, and so would the 3x plus 2. And you would just subtract the 3x and you get x equals 2. So how could I make it harder? The x squareds would be different where they wouldn't cancel out. You'd have to factor, bring everything over, set equals 0 and factored, and that's why we practice factoring. So we'll practice factoring a little bit here. Okay, how's chord? Is that enough? Okay, what are you going to promise me? Around anything bigger than a number or an x, anything bigger than one term, you've got to put parentheses. Okay, let's go to B next. And B is, the next one is not chord. B is secant. It's not really named in the book at all. I just sort of name them myself. Secant, secant. Secant is a line that goes and intersects the circle how many times? 2, yeah, twice. Tangent only intersects once, secant intersects twice. So when the secant comes up to the circle, we have this part here that we'll call A, and it's sort of outside the circle. And then we have this part here that's inside the circle we'll call B. And then the secant underneath them is the exact same thing. You sort of have a part outside the circle and I have another part inside the circle. So they see 4 different parts. And I'll give you the book formula and then I'll give you mine. The book formula says A times the quantity A plus B equals C times the quantity C plus D. So I don't memorize it like this at all. A is outside. Do you agree? Yes or no? So I write my formula as outside. And A plus B is the entire length. So I say the whole part. So the outside times the whole. Now if I asked you what the whole was, if this is 3 and this is 4, how would you know how long the whole is? What would you do with the 3 and the 4? Okay, so make a little note. In order to do the whole, you have to add. The biggest common mistake on all the quizzes and tests is that people multiply it. Okay, equals the C, it would be another outside part. And then the C plus D would be another whole. So secant, secant, I've always memorized as outside times whole equals outside times whole. Okay, I've got 3 of them, going from easy to really hard. Sound good? Okay, let's do one. Okay, secant, secant. I've got 9, 11, 10, and X. 9, 11, 10, and X. And I don't care which secant you start with. You can start with the top one or the bottom one. So who's going to do outside times whole? What's it going to look like? What's outside? 9 times whole would be 9 plus 11. Awesome. Equals outside 10 times whole 10 plus X. Excellent. 9 plus 11 is 20. 20 times 9 is 180. You could have also done 9 times 9 plus 9 times 11. Distributive property, you would have gotten it. So. Equals, distribute this way, 100 plus 10x, okay? Subtract the 100 and we get 80 equals 10x. Divide by 10 and x is equal to 8. How is the easy one? Is that okay? Not bad. What they could ask you for simply is to solve for x. They could have put some letters on here and asked you not only to find AB, but what if they asked you to find AC? What would you have to do with this 8? Plug it in and your answer would be 18. That's about as weird as they'll get. Okay, number 2. Secant, secant. I've got a 3, an x plus 2, an x minus 1, and an x plus 1. A 3 on the outside, and an x plus 2 on the inside, an x plus 1 on the outside, and an x minus 1. So I just want someone to tell me the setup, outside times whole, and we'll keep the whole thing like the whole thing added together. So who's on the outside? Okay, we'll start there. Times, who's the whole? 3 plus x plus 2. And yes, for the first few, I would write it out. I know you can add, but I'd write it out still. Equals Outside, how am I gonna write it though? Yep, x plus 1. Now, whole. Excellent. How's the whole on that one? Is that okay? Now you have a little cleanup work to do. Inside this parenthesis, what is a 3 and a 2? Those are the only thing you can add would be, so 3 times the quantity 5 plus x equals, I'll bring down the x plus 1. Now what happens when you clean this side up? You've got an x and a plus 1 and an x and a minus 1. The two ones go away. And what do you get? 2x. Now this is distributive property, and so is this side. This is not FOIL because there's no plus or minus in this parenthesis. So this is 15 plus 3x equals, now what is 2x times x, remembering your favorite algebra days? 2x squared. 2x times 1 would be 2x. And then a light bulb should go on. Then anytime you have x squared and x to the first in any of the equations, you're going to have to bring it, just like you did, bring it over, set it equal to 0, and then we've got to, what? Factor. So we're going to subtract both of these. And so I get 0 on the left. So 2x squared minus 1x minus 15 would be equal to 0. So I'm going to come up here. So I've got 2x squared minus 1x minus 15 is equal to 0. So you could do your x. You could do two numbers that multiply to negative 30 that add to negative 1. You could do it this way, two numbers that multiply to negative 30 and they add to negative 1. What do you think of the numbers? Not 10 and 3, 5 and 6. Who's negative? I think so. So because there is a 2 here and not a 1, we have to do the split middle term. So who would you like first out of the 5 and the negative 6? You want to put the 5x or the minus 6x? I think so too. Minus 6x plus 5x minus 15 is equal to 0. So you split them up beautifully. Always in this class, group them 2 and 2. And then what can I pull out of the first two? And I believe it's x minus 3. What do you think? And then what can I pull out of the second one? 5. Woohoo! X minus 3. They're the same. So one of them comes, oops, I wrote plus. One of them comes out. And the other parenthesis is what is left. And then what are my two solutions? Because you know it's a quadratic, so you know there's two solutions. So one of them is
7 plus 3, and x equals negative 5.
negative 5 halves. Okay, negative 5 halves is negative 2.5. Agree? Okay, so let's think about that. When you put in right here, negative 2.5 minus 1, do you agree with me that this would be negative 3.5? Can you whip out a ruler ever and measure a length of a segment of negative 3.5 units long? So I'm going to go as high as 98% of the time your negative answer will drop out. There'll be the one weird times that sometimes it'll work and you'll still get a positive here. So on the homework, I think I just throw out all the negative answers. But on the test or quiz, we need to check to make sure that the negative answer might end up making even the segment still positive, then it still works. Could be a chance that both answers don't work, and the answer would be no solution. Okay, you ready for a hard one?
Yeah, I started with.
Yeah.
So then on the test, you, like, if the negative, when it doesn't work out, you just put 3.
You just put 3. Yeah. Was this hard or medium or easy? Is okay?
How
10?
would it work out?
I'll show you on the next set,
Okay.
especially. Okay, going for a hard one? Okay, secant, hard. That's such a good question. And this, I need to know where you are. I've got an X, a 10, an 8, and an 8. And you think, oh gosh, it's not gonna be that bad. Yeah, when I looked at it, I thought, oh, this will be easy, don't you think? Okay, you set it up and stop and see what you get. And then we'll set it up together and finish it together. Outside times whole equals outside times whole. You want me to tell you the numbers? 128. I'm totally with you. Okay, you want to tell me your setup then? Anybody?
I did X and then parentheses X plus 10
Excellent.
equals 8 parentheses 8 plus 8.
Excellent. So 8 plus 8 is 16. 16 times 8, what did I just tell you it was? 128. Okay, and this is the distributive property, so what would the left side be? Okay. Did anybody not get the original setup? Are you okay? Some of you can just jump to 8 times 16. It doesn't matter. Whatever you need to do, okay? Now you got an x squared and an x to the 1 power, so you're going to have to subtract the what? Yep, subtract the 128 and set it equal to... Okay, go. Two numbers multiply to a negative 128 that add to 10. You don't have to do split middle term because the coefficient's 1. But try and find those numbers. Try and find two numbers that multiply to negative 128 and they add to 10. And you're going to sit there all day and guess what? There are none. So what do you do in Algebra 1 if it cannot factor? Because remember, all quadratics will have solutions, and 80% of the time you can factor and get those solutions. What did you do with the other 20% last year? No. No, you have to have solutions. So in Algebra 1, you use quadratic formula. Do you remember that at all? Okay, so some of you do, some of you don't. So I'm going to start with square one. Are you ready? The quadratic equation is ax squared plus bx plus c is equal to 0, where a is the number in front of x squared, b is the number in front of x, and c is the constant that has no x with him. So looking up above, what would be my a, b, and c? What's a? 1, the number in front. B is going to be 10, and C is, okay, in order to find A, B, and C, the equation has to be set equal to 0 and put in proper descending form. Does that make sense? You have to start with the square, then the x to the 1, and then nothing. Okay, quadratic formula. Opposite oh, yeah. Quadratic formula. Quadratic formula solves the equation every single time. So if you never want to factor again, don't factor. Use quadratic formula. I would quadratic formula over factoring in 2 seconds. 2 seconds. Okay, so let's read this. Okay, careful. How do you read this? Ooh, no. No. Opposite of B. So say that again. Opposite of B, plus or minus, because how many answers are we going to get?
2.
Okay, so there's how we get plus or minus. The big square root of B squared minus 4AC all over 2A. Come on, you didn't learn the song? Yeah, you learned the song. Yeah. Yeah. All over 2A. Okay, who is the opposite of 10? Negative 10. Plus or minus? Square root. What is B squared? You go to your calculator and you type in 10 squared and you get, what do you get? Okay, when you square something, what kind of answer will you always get? Positive, do you agree? You should never have a negative number right there. Okay, minus 4 times A times C, and I'd still put parentheses around it, all over 2 times 1, which is A.
Do we even have to add the 1 if it's a 1?
Nah, you don't have to. Okay, so now we come down, we have negative 10 plus or minus. Now this I just want you to type right in your calculator. You take 100 minus 4 times 1 times negative 128 and tell me what you get. What do you get? 612, right? All over 2 times 1 is 2. Good so far, yes or no? Then you roll your eyes, type a little text to your friend and say, come on, this is crap, right? What are we going to do with this? Do you remember that day we started with radicals and we had to reduce them? You can't leave 612. So you go, okay, 612. Factor tree or perfect square, I don't care. It does not matter. 612. What would you like? What'd you say? Okay, because your calculator is awesome and it just gives it to you. 612. 612 divided by, what would you like to do? I got 4 and 153. 3 and 51. 3 and 17. 2 and 2. 6 radical 17. Awesome. Negative 10 plus or minus 6 radical 17 all over 2. You could sell your calculator for usage per period, okay?
I would do that.
If I was taking the real ACT test, I would really find a friend who has that calculator and your graphing calculator and take them both. Like Tim had 5 calculators going in, people.
You can do that?
You can take as many calculators as you want. Absolutely. Okay. One more time, you're going to roll your eyes. Are you ready? You look at these 3 positions only and put arrows on them. Those 3 positions, if they're divisible by the same number, then you can reduce it. If they're not all divisible by the same number, then you can't. They're all divisible by what? 2. So negative 5 plus or minus 3 radical 17 all over 1. And you don't have to put the 1. Negative 5 plus or minus 3 radical 17 all over 1. You like it better or worse? Okay,
This is so bad.
but you can't do the x. So you don't have a choice on this one, right? You still be sitting here, you can't find numbers that add or multiply to negative 128 and add to 10. So quadratic formula always works.
Can you just walk it through one more?
Yep.
Are we gonna get your quadratic?
I would give you this formula every time. Yeah. Okay, so once the equation is in proper form, A is the number in front of x, B is this one, and C is this one. A is always in front of the x squared. So once we figure out what our A, B, and C are, then you just plug it in. You read this as the opposite of B, so that would be negative 10. Plus or minus. B squared is 100. Time or minus 4 times A I plugged in and C I plugged in. All over 2 times A. Then I just take my calculator and type this whole thing in just as it's sitting. So I don't have to do any work on PEMDAS. And I got the 612. And then I went over and reduced the 612 and brought it back in.
What is the plus or minus mean?
What does the plus or minus mean? It's such a good question. Because if you factored it, how many answers do we get? 2. So one answer would be negative 5 plus 3 radical 17 all over 1. And the other answer would be negative 5 minus 3 radical 17 over 1. Okay, ready for C? Yes or no? Secant, secant. Now we're on. Guess what we're on? No, tangent, secant. We will practice quadratic formula next week. imagine doing all the angles and the sides in one day? I cannot imagine this book wanting to do that. Again, it doesn't have a name. I just call it tangent secant. So tangent and then secant. I don't know why all mine, if you notice, they're drawn to the right. It has to be something because I'm right-handed. I don't know. Danny. Yeah. They're not, if you put the X back in, they're not going to be always the same length. They can be, but probably 99% of the time they're not going to be. Yeah, that's a good question. Okay, I'm going to call this part A, the outside part B, and this part C. This formula is a little wacko. A squared equals outside times whole. Because the secant, we already know, equals the outside times the whole. We're familiar with that because it's a secant. But the new part is the tangent part, and what you do is you square that one. Tangent part squared. So let's do a couple and see. Tangent secant. I have 3. Yeah, if we don't, I don't know if we need to do all 3, but I'll try it. Okay, can you recognize which is the tangent part and which is the secant? Okay, so I think that's the most difficult part about this one. That's it. So the tangent part is the 16. So you take the tangent part and you square that, so it would be 16 squared. And then the secant is the exact same thing as we did before. It's outside times whole. So who's outside? 8. And then whole, please add 8 plus x. And I don't care if you wrote x plus 8 or 8 plus x. That doesn't matter. 256, please check me though. Yeah? 256? And then what property is that? 64 plus 8x? That's not bad, is it? 192 equals 8x. Anybody have x? Excellent. Not bad? Okay, all I'm doing is moving the x. You ready for number 2? X was inside of the secant part. So now number 2. X is outside of the secant part. Outside of the secant part. Can anybody set me up? Tangent part squared is, everybody? 12 squared equals outside times whole. Excellent job. 144 equals x squared plus 10x. And you go, yahoo! I saw that, yeah. What do you have to do? 0 equals x squared plus 10x minus 144. Yeah, no. This section is just ugh, isn't it? It just keeps adding more ugh to it. I'm going to do it for you. Are you ready? X minus 8. X plus 18. So I get 8 and negative 18. What do you think? What do you think about the negative 18? Can you have a negative 18 as the length of an outside segment? So he gets thrown away and your only answer is x. 8 as x, yeah. Yeah, Claire.
So if they go inside but not outside?
What?
Like,
Yeah, you can go any. I was going to do the next one I was going to do up here, too.
so that would be negative, right?
No. Okay, so answer Tessa's question really quick. If the x was up here and already squared, then you would be able to have a positive segment. Does that make sense? And to answer Tessa's question before. Yep. Okay, so no homework, you're gonna have a worksheet tomorrow, sound good? All right, have a great night.